Hello everyone, so it's 1 minute to Cody2si day 4, and this time I logged in, so I will not fail again, hopefully. Let's see how it goes. Let's open the input already. Fifteen seconds. Let's see, let's go. Encrypted uppercase memory units. For example, the character A takes one memory, B2, C3. Z will take that. They need memory units. This thing, there are 5 lines. First line takes that. Second line, fifth line. 100 lines. What is the number of memory units required to store your message? So total. Okay. Is this big? F.read.split lines for any lines for C and L. Let's do S is 0. We just sum everything, right? Okay, so let's do S plus equal ord of C. Don't remember. Fuck. Ord of A. 65. So we do minus 64. And just print S. Let's try. Let's go. Part 2 is compressed to N2 compression. Each line individually. Number of characters kept by 10. So then you count. Let's compress to that 17. Wait. At the end and at this 10, then rounding down. Then the middle of the line is replaced by the number of alphabetical characters removed. Okay, so that I divide by 10, so this is 10, so it's 1. So we replace, so we keep just this and this, and we take this. Okay, this means that you just keep 2 of them, so OOHH, and then you remove these and you replace with that. What are these two? What is the weight of 2 and 9? Numerical character 1 takes up 1 memory unit. Okay. Def mem. This takes up a string. do this. This takes up just a line, I guess. So let's go for scene s plus. So if c dot is digit, we do s plus equal into c, else s plus equal chord of c minus, what was it, 64, I guess. Was it 64? I hope. And then we just return s. Yeah, 64. So we do this. Now what we're gonna do is for L-in lines, we do n is len of L, to keep is n divided by 10 rounded down, and so final is n is L of the first to keep plus L of so if we do this would be the last one. So well, we can just do like L, we reverse it, and then we just take the first to keep, and then we just do numeric is len of n minus, sorry, is n minus twice by 2 keep. So this is the original, this is, yeah. So now the real final, now our S will be final, let's go bag like that, and is this, numeric is that, so it's going to be bag plus str of numeric plus and then ans is 0, ans plus equal mem of s. It is not iterable for CNS. Yeah. Let's go part 3. Um, 202 and okay, so this is basically the run length encoding, right? C dot by. So mem we can keep it. We just change def compress of s, and this is run length encoding. So what we're gonna do is we're just gonna do so is this for in range len of s. So we start actually from the first one, we go up to the end. So what we do is well, now we can do for E in range len of S -1. So we don't want the last, or do we want the last? No, we do that. So we always check the next, right? Yes, so if this is current, next is, so if E is equal to len of S -1, then we do something, we just break for now. Next is S of E plus 1, and we go if current is equal to next, we do a run is 0. If current is equal to next, then we do run plus equal 1. Else we break the run, like add, so we have to add. So if this is equal to this, the run is, we can just set the run to 1 all the times. That's better. Pass, well, like run equal 1. First we do something. So if we find this is the same as this, so the run is 2, then we find this is the same as this, so we just like, so this is different, so we append a run of 2. So we just do final plus equal, we have to say, first we do str of run, and then plus, like, yeah, str of run plus the current. Then we set run to 1, and the current is going to be the next. Should be fine. If this happens, so if we end up at the last character, so here we just append whatever run and the current. So we just do yes, so we just do final plus equal str of run, final plus equal str of current, something like that. Then we return final at the end. Let's see if it works. Oh wait, what did I do? Okay. String index out of range. Well, we will break here. One, yeah, there's still ones in there. Let's try the test just to be sure. One n, so it should be 2n. This is always should be 2n. Why 1n? Run is 1. freeze it. This looks fine. So now here, do this, and we do s equal mem of s of f. We just print ans. Let's try to do it with the input. Nice. Pretty good. Whatever the score is, I'm satisfied. Let's see. Time base, problem 4. Wow. They're fast. 6 minutes? Holy cow. They're very fast. But I'm satisfied. Yeah, maybe like what was like 8 minutes? It was 14 here. Yeah, maybe if I didn't test, like if I just tried to submit, maybe I was like 6 or something like that. But I'm satisfied. Like, just wanted to make sure to not fail the last submission. Let's try the part 1. Well, part 1, 7 minutes. Wait, time based, problem 4. No, this is 1 and 2, okay. Part 1, it was 4th, very close to leaderboard. Wow. Yeah, because I need, like, part 1, I needed to check what was the OR function in Python. Like how, like if it was like minus 64, 65 to not mess it up, but it was fine. Like part 1 and 2, let me see. Part 1 and 2, 6th. Well, it's fine, I guess. I was a little bit slow on the last one to write this logic here. Maybe also the bug of the run. Like if I didn't have this bug, maybe it was, if I didn't wrote that bug, it was faster. Probably it was like, could have been like 5th or 4th. I don't know. So basically, the last part was nice. It was the run length encoding, basically. Run length encoding is basically when you have, you know, any sort of string, and you basically say, okay, here instead of typing n twice, I say, okay, there are 2 n's. And in the case of nn, so 2n, you use the same number of bytes. But for example, in this case where you have 5s, 5 times the s, you can just write 5 and s, and you basically avoided to use 3 more characters. You use 2 instead of 5. And this is called run length encoding. And it's a very common compression algorithm that is used in multimedia data processing. Also, for example, in images where you have like a really white image and you want to compress it, you use this algorithm is quite effective because you can sort of compress the white pixels and just say, okay, in this line there are 1,000 white pixels, and you use less memory. Yeah, today's problem was fine. It was interesting. See you next time.